Welcome to Trending Unpacked, the show where we explore the stories behind the trends shaping our world. Today, we are focusing our attention on a disease often called the cruelest disease you've never heard of, Huntington's disease. It's a rare inherited condition that systematically and slowly erodes both the body and the mind. A generational tragedy that has historically offered no reprieve.
But that narrative is changing dramatically. Right now, new breakthroughs in gene therapy are bringing serious, tangible hope to families who have lived under its shadow for decades. Huntington's, or HD, it's making headlines again in 2025 because we are finally seeing concrete, advanced movement in clinical trials that aim to target the very genetic roots of the illness.
Our mission today is clear. We are going to unpack exactly what Huntington's disease is, dissect the terrifying mechanics of how it's inherited, and explain why this specific moment in scientific history with these gene silencing technologies is a true turning point for the patient community.
It's a critical story that brings together cutting-edge genetics, the high-stakes world of biotech investment, and, deeply personal ethical debates about knowledge and prevention. It really touches on a lot.
Thanks for listening to Trending Unpacked, where today's most important stories meet insight and curiosity. Okay, let's unpack this. When we talk about HD, we need to establish quickly that this isn't just a motor disease or just a cognitive disease. It's an attack on core functionality. What are the core facts we need to understand about this neurological disorder? Specifically, which parts of the brain are damaged?
Right. What's fascinating here is that the physical manifestation of Huntington's disease is inherently tied to where the damage occurs. It is a progressive, inherited neurological disorder that specifically targets the nerve cells in the brain, with primary damage occurring in the striatum, which is a key part of the basal ganglia.
Okay, the basal ganglia. I know they're responsible for controlling movement, learning, and maybe certain emotional processing, correct?
Precisely. The death of neurons in the striatum leads to the signature physical symptom of HD, which is chorea. Those involuntary, jerky, sort of dance-like movements.
Right, chorea.
But to emphasize your point, the disease is so devastating because the damage isn't just limited to movement. It also causes severe cognitive decline, including executive dysfunction like the ability to plan, organize, and execute tasks, as well as mood swings, depression, and eventually profound dementia.
So it's not just the involuntary movements, it's everything that makes up a person's life, their memory, their personality, their ability to just navigate the world. This comprehensive erosion is why it's often labeled the cruelest disease.
It absolutely is. This combined physical and cognitive decline, often accompanied by psychiatric symptoms, it just sets the stage for why the medical community views HD as such a catastrophic diagnosis. It removes autonomy piece by piece, really, over decades.
Let's get into the genetics, because this is where HD is unique and, frankly, terrifyingly straightforward. We are talking about a single defective gene causing all this havoc.
That brings us directly to the genetic fingerprint of HD. The defect is located on chromosome 4, and it is caused by a specific error in the DNA sequence, an expanded CAG repeat in the HTT gene.
The cytosine adenine guanine triplet repeat, CAG. It's incredible that a mistake involving just 3 letters repeated too many times can cause such widespread neurological catastrophe. Why? Why does having too many of these repeats above a certain threshold break the entire cellular system?
Well, if we step back and look at the cellular level, the HTT gene normally provides instructions for making a protein called Huntington. When you have an abnormally high number of CAG repeats, typically we're talking 36 or more, the resulting protein, the mutant Huntington protein, it becomes misshapen, sticky, and highly toxic to the nerve cells.
Toxic, so it's not just that it doesn't work properly, it actively poisons the cell.
Exactly. Digging deeper into that toxicity, the mutant protein doesn't just float around benignly. It actively disrupts critical cellular processes. For instance, it interferes with mitochondrial function, the cell's powerhouses, basically starving the neurons of energy.
Okay, so it cuts off the power supply.
Right. And it also disrupts axonal transport, which is the vital system cells use to move essential molecules and structures down the long arms of the neuron. Think of it like clogging up the cell's internal highway system.
Wow.
So by gumming up both energy production and transport, the mutant protein suffocates and kills off those highly sensitive neurons in the striatum over time. That slow, methodical neuronal death is the core biological reality behind the symptoms we observe.
So the disease isn't just a result of a missing function, but a toxic gain of function, where this malformed protein is actively harming the cell.
Precisely. And the high, predictable risk of transmission is the next layer of complexity. This isn't a recessive gene where you need 2 copies. This is autosomal dominant.
That immediately introduces the 50% dilemma that defines the disease's generational burden. That number is just stark.
It is. Because HD is an autosomal dominant disorder, you only need to inherit one copy of the faulty gene from one parent to develop the disease. Imagine the severity of a coin flip. Each child born to an affected parent faces a flat 50% chance of inheriting the faulty gene.
Oh, coin flip.
Unlike diseases where risk is complex or environmental, this risk is known, fixed, and terrifyingly high.
50%. That's not just a statistic, that's the ultimate life-altering coin flip that happens before you even start planning your own life. This transforms the conversation from a single person's illness to a family's history, a statistical cloud hanging over every major life decision.
It absolutely does. This unique burden places immense emotional and planning pressure on families compared to those dealing with non-hereditary conditions. It links the cold, hard reality of genetics directly to those emotional viral stories we're seeing online now, where young adults face the agonizing choice of genetic testing, knowing it could determine not only their future, but also their decision about having children.
Okay, let's talk about the typical timeline then. If someone inherits the gene, when does the damage typically become noticeable? When do symptoms usually start?
Symptoms usually begin manifesting subtly between the ages of 30 and 50, which, as we mentioned, hits people right at the peak of their professional and parental lives. This middle-age onset adds a profound financial and familial tragedy to the medical one.
Right in the middle of life.
Yeah. However, the exact age of onset is often correlated with the number of CAG repeats. It seems the more repeats you have, the earlier the onset generally is. There's some variability, but that's the trend.
And once it starts, the progression is relentless, often lasting a decade or more, sometimes much more.
Yes, the progression typically worsens over a period of 10 to 25 years. It is a slow, methodical decline that eventually leads to total loss of physical and cognitive function.
Which brings us to the current stark reality of treatment, which I think provides the critical context for the hope we're seeing today.
Exactly. As of now, there is no cure for Huntington's disease. Zero. Current medical interventions focus solely on managing symptoms, using drugs to try and control the chorea, for instance, or medications to address the severe psychiatric components like depression or excessive behaviors. But they don't slow the disease itself.
Just managing the fallout, essentially.
Pretty much. That lack of a cure, that baseline of absolute certainty regarding decline, explains the urgency and the sheer significance of the breakthroughs we are witnessing right now in 2025. This scientific pivot shifts the goal from management to potential interruption, maybe even stopping it.
That moves us directly to the new frontier, gene therapy. We've moved beyond just managing symptoms and are now talking about striking at the genetic root cause, that toxic protein production line itself. What are the specific advanced therapeutic strategies currently being tested? What's actually happening in these trials?
Well, we are seeing two primary therapeutic strategies in advanced stages, both of which aim to interfere with the bad gene's instructions. The first and currently most advanced are the gene silencing therapies.
Gene silencing.
Right. The second, which is still maybe further down the pipeline but represents, the ultimate goal perhaps, are the more permanent CRISPR-based trials, actual gene editing.
You described gene silencing earlier as turning down the volume on the defective gene. That sounds like a dimmer switch for the disease, not quite off, but lower.
It is a perfect analogy for the short-term goal, yeah. The mechanism focuses on intercepting the message after the defective gene has been read by the cell, but before the toxic protein is actually built.
Okay.
The gene silencing goal is to prevent the bad HTT gene from producing the toxic mutant Huntington protein in the first place by stopping the messenger RNA, or mRNA, which carries the instructions.
So you stop the instructions getting through.
You're essentially turning down the volume on the defective gene's output by destroying its instructions before they reach the protein factory, the ribosome.
And we need to name the players involved, because this isn't abstract lab work anymore, is it? There are major biotech companies driving this research, signaling huge investment in real clinical efforts.
Absolutely. Mentioning specific entities demonstrates the high investment and the serious scientific pivot occurring globally. We are seeing crucial research involving companies like Wave Life Sciences and Uniqueware, both deeply focused on these advanced therapies, but using slightly different technologies to achieve that gene silencing effect.
Okay, let's dig into Wave Life Sciences' approach first, as they represent a major trend in this field. What is the specific technology they are using to silence the gene? How does their method work?
Wave Life Sciences primarily utilizes antisense oligonucleotides, or ASOs. ASOs are specialized, short, synthetic strands of nucleic acid-like tiny pieces of engineered DNA or RNA.
Right, ASOs.
And they're designed to be complementary, like a mirror image, to the specific piece of messenger RNA, mRNA, that carries the instructions for building that toxic Huntington protein.
So the ASO is like a tiny, specialized missile seeking out the bad instructions.
Exactly. When the ASO finds and meets the mutant mRNA strand inside the cell, it binds to it. This binding action flags that mRNA strand for destruction by the cell's own natural disposal machinery.
Ah, so the cell cleans it up itself once it's tagged.
Precisely. No mRNA, no
Right.
toxic protein production from that specific message. It's a beautifully targeted biological intervention, aiming to only hit the problematic protein.
That sounds incredibly promising, but moving from the lab to the patient introduces a huge physical hurdle. Delivery.
Yeah.
How do you actually get that therapy into the brains of patients? The brain is notoriously hard to reach.
This is the major technical hurdle we absolutely must discuss. The brain and central nervous system are protected by the blood-brain barrier, a very effective shield.
Right.
You can't just swallow a pill and expect it to get into the brain in sufficient quantities. The ASOs and other similar therapies must be delivered directly into the cerebrospinal fluid, CSF, the fluid that bathes the brain's spinal cord.
Directly into the CSF. How is that done?
This means patients must undergo repeated intrathecal injections, commonly known as a lumbar puncture or spinal tap. The drug is injected into the lower back, into the space containing the CSF.
A spinal tap. Regularly. That is a significant commitment for patients. It means the cure or management involves an invasive clinical procedure, likely on a regular schedule.
It does. It defines the reality of managing this disease with this approach, even if it's successful. It's a trade-off. A temporary, perhaps inconvenient or uncomfortable invasive procedure for the potential to slow or stop the fatal progression of the disease. It's a serious calculation for patients.
Okay, now what about Unicus? They are tackling this with a different vector entirely, you mentioned, not ASOs.
That's right. Uniquers is focused on using AAV, or adeno-associated virus, vectors for gene therapy. Instead of repeated ASO injections, which are temporary, Uniquers' approach aims for a one-time or maybe very infrequent delivery.
Using a virus, that sounds potentially risky.
Well, they use a modified harmless virus. The adeno-associated virus is not known to cause disease in humans and is engineered so it can't replicate. It acts purely as a delivery vehicle.
A delivery truck, essentially.
A biological one, yes. It carries genetic material, a blueprint, into the patient's own brain cells. This blueprint instructs those cells to essentially turn themselves off from producing the mutant protein, often by making their own small interfering RNAs.
So it teaches the cells to silence the gene themselves, potentially permanently.
That's the goal. If successful, this permanent or very long-lasting genetic fix is, in many ways, the holy grail, a one-and-done treatment. But it also carries a higher regulatory and safety burden initially.
Why higher?
Because it's harder to reverse. ASO treatments wash out over time if you stop the injections. Viral vector gene therapy aims for permanence, which means any unforeseen side effects could also be permanent. That's why ASO trials often move a bit faster through the initial stages. They're seen as potentially lower risk because they're temporary and reversible.
Okay, that makes sense. Let's talk about the actual breakthrough that generated the headlines in 2025. What did the key clinical trial actually show in the data? What was the big news?
The key breakthrough generating the intense excitement, particularly around the ASO approaches like waves, is the data showing promising results for the trial's primary goal, which is reducing mutant Huntington protein levels in the patient's CSF. They could measure the bad protein and show it went down after treatment.
So they successfully proved they could flip that dimmer switch and successfully turn down the production of the toxic protein, and critically, they could measure that effect in the spinal fluid. Why is measuring the protein level in the CSF such a critical endpoint? Why not just look at symptoms?
Well, symptoms take a long time to change in a slow progressive disease like HD. The cerebrospinal fluid, CSF, acts as a window to the brain. Since the disease happens in the brain and the drug is delivered into the fluid surrounding the brain and spine, measuring the concentration of the toxic protein in that fluid is the most accurate, quantifiable way early on to prove the drug is hitting its target and doing what it's supposed to do biologically.
It's a biomarker, basically. Proof the mechanism works.
Exactly. Successfully reducing the mutant protein levels in the CSF is proof of concept in humans. It validates the entire gene silencing strategy, showing we can mechanically interrupt the production of the disease-causing agent inside the central nervous system.
And while the full clinical impact, the actual slowing or stopping of symptoms, will take longer to measure, much longer, successfully reducing the toxic protein is the necessary first step. That must have had a profound emotional impact on the patient community, just seeing that protein level drop.
It absolutely has. You see it online in patient forums. It's reignited hope in a way that just hasn't happened before for HD.
Reignited hope, that's powerful.
And if we connect this to the bigger picture, the potential impact could be transformative. For decades, the disease trajectory was a one-way street toward total fatality within, say, 10 to 25 years after onset. If these therapies are successful in maintaining low levels of the mutant protein through, say, ASO injections every few months, They could fundamentally shift HD from an unstoppable, fatal neurodegenerative condition to a manageable chronic disease, like managing diabetes or high blood pressure, perhaps.
A manageable disease. That is a radically different world for these families. What would chronic management look like for the patient and the healthcare system, practically speaking?
For the patient, it means the prognosis shifts from a guaranteed 10-25-year decline to potentially a lifetime of functional stability, provided they adhere to the treatment regimen, which, again, for ASOs, likely involves those regular lumbar punctures. It's not without burden, but the alternative.
Right, the alternative is unthinkable.
And for the healthcare system, this raises huge questions about long-term care planning and health insurance. Managing a chronic disease is expensive, yes, but far less expensive, and certainly less devastating emotionally and socially than providing decades of end-of-life custodial care for a condition that robs a person of all independence. It changes the whole economic equation, too.
The idea that a child born today with the gene might never face the full 10 to 25-year decline. That's the engine driving this trend, isn't it? This advanced stage of trials means the speed of discovery is accelerating dramatically, offering a timeline of hope that just wasn't there even 5 years ago.
Precisely. Feels like a real turning point.
So we have this huge scientific breakthrough moving from lab to clinic, which is amazing. But science alone doesn't usually make something trend across social media platforms like TikTok and Reddit. What were the catalyst events that thrust Huntington's disease into the public spotlight in 2025? Why now?
Yeah, it's interesting. There were two main drivers creating this confluence of awareness, really. First, the topic trended online due to a wave of incredibly emotional viral stories from families documenting their experiences. These were raw, personal narratives shared by caregivers and sometimes patients themselves, facing that 50% dilemma, often capturing poignant moments of chorea or cognitive struggle on video. Very direct, very human.
Very shareable content, unfortunately born from tragedy.
Exactly. And second, this wave of personal storytelling coincided directly with renewed focus during World Rare Disease Day back in February. That always brings a spike in media attention and public consciousness for conditions like HD.
So you combine a global awareness day, which often triggers media coverage and hashtags, with highly personal, shareable video content.
Yeah, that created a perfect storm for trending and maximizing reach.
Absolutely. And what's the flavor of the conversation on those online communities? We know they share these moving videos, but how do they frame the disease? What kind of analogies do they draw or distinctions do they make?
On platforms like TikTok and Reddit, you see powerful, unfiltered looks into the realities of caregiving and living with HD. People often draw comparisons to other progressive neurological diseases like ALS and Alzheimer's because the symptoms, loss of motor function, cognitive failure, feel somewhat familiar to the general public. It gives people a reference point.
Right, it helps people understand the severity. But the HD community emphasizes a critical distinction, right? They make sure the public understands that HD is different because of that unique inheritance pattern. It's not just a disease, it's an inherited one with that stark probability.
Absolutely. While ALS and Alzheimer's are devastating, they don't generally carry that same direct 50-50 statistical burden for the next generation. The online HD communities are very focused on emphasizing HD's unique hereditary impact, constantly reminding people about the 50% risk and the impossible life decisions it forces upon pre-symptomatic adults and potential parents. That genetic aspect is central.
And this emphasis leads directly into the profound ethical crossroad this disease presents, which is one of the most trending topics surrounding HD outside of the gene therapy success itself. The central debate is deeply personal. Would you want to know if you carry the gene?
This is perhaps the heaviest question of medical ethics trending right now, maybe one of the heaviest, period. For someone whose parent has HD, they can get pre-symptomatic genetic testing. They can find out years or decades before symptoms start if they inherited the faulty gene.
But knowing confirms a fatal diagnosis 10 or 20 years down the line. What are the practical implications of that knowledge? How does it actually affect someone's life?
They are staggering, and they extend way beyond the emotional, though that's huge too. The unique pressure of a pre-symptomatic diagnosis impacts every aspect of life planning.
Yeah.
How do you ethically navigate relationships? Telling a partner? Career choices, major financial decisions, like can you even get long-term care insurance or life insurance if you test positive? Knowing with 100% certainty that the disease will likely begin in your 40s or 50s, it changes everything.
But choosing not to know.
Exactly. For many, the ability to not know offers a psychological shield, right? It allows them to pursue life without that clock ticking quite so audibly in the background. It preserves a sense of normalcy, maybe.
And the decision to know or not know often dictates the decision about having children. That's the crux of the generational burden we keep coming back to.
That's the key linkage, absolutely. Knowing you carry the gene allows a family to proactively engage in family planning strategies that prevent transmission to the next generation, which naturally leads us to the ethical debate surrounding the new therapies themselves. The conversation online and in the community is often framed as, how do we balance hope and reality with gene editing?
We're talking about the tension between the promise of revolutionary change, like with CRISPR, and the risks and the regulatory complexity involved.
Correct. The promise of CRISPR-based therapies is potentially eradication, permanently correcting or eliminating the mutant gene from a person's DNA. That's a revolutionary concept, almost science fiction made real.
Eradicating a hereditary disease.
Right. But the reality involves significant regulatory hurdles, the unknown long-term risks of permanent gene modification, off-target effects, things like that, and the potentially astronomical delivery costs and complexities. It forces the public, and especially the affected community, to weigh this incredible hope against safety concerns, especially when considering applying these powerful technologies not just to patients, but maybe even to embryos to prevent the disease entirely.
And that eradication promise brings us to the most complex ethical frontier detailed in the source material, preventing transmission in future generations altogether. The growing conversation about genetic ethics focuses specifically on whether potential parents who know they are at risk should undergo pre-implantation testing or editing to prevent transmission.
This moves the conversation beyond just treating the individual with HD to potentially eliminating the disease burden for future generations entirely within a family line. The debate over pre-implantation genetic diagnosis, PGD, where embryos created via IVF are screened before implantation to select only those without the faulty HD gene, is central to this.
Right, PGD. Given the 50% risk and the devastating nature of HD, many people argue PGD is the most ethically responsible path for carriers who want children.
They do, and it is a rapidly growing field offering real options for families. However, PGD inevitably raises broader societal questions. If we can screen out HD, what about other genetic conditions? Where do we draw the line? This is the slippery slope argument that naturally follows discussions about genetic selection.
The fear of designing babies, essentially.
Or at least creating societal pressure to only have genetically perfect babies, whatever that means. It links the targeted medical solution for HD to the much larger philosophical debate about the limits of medical intervention and how we define acceptable human traits or conditions. The HD community is at the forefront of this discussion simply because their genetic risk is so starkly defined, and the technology now exists.
It's a heavy burden, carrying not just the disease risk, but also the weight of these pioneering ethical choices.
It really is. This cultural moment is clearly fueled by this combination of scientific advancements and heartbreaking personal stories. We should also highlight the role of public figures in this trend, as they often help bridge the gap between personal narrative and institutional funding or broader awareness.
Right, the celebrity factor.
Celebrities and influencers have played a crucial role in amplifying both the stories and the scientific hope. We've seen them joining sophisticated campaigns that are successfully raising funds for research foundations, notably the HDFA, the Huntington's Disease Society of America.
So it's the classic, powerful combination. The emotional viral stories capture the public's attention, maybe go viral on TikTok, and then celebrity backing helps channel that attention into tangible funding for research, helping accelerate the very clinical trials like those involving Wave Life Sciences and Board that we discussed earlier.
Exactly. It's a crucial cycle. Awareness feeds action, which feeds research, which generates news, feeding more awareness.
It sounds like the trend is self-reinforcing now.
I think it is. The advanced trials generate real hope. The hope fuels the patient's stories and advocacy. The stories raise awareness and funds, and the funds help accelerate the trials further. HD is finally receiving the focused, high-stakes attention that its severity and its clear genetic target, frankly, have always warranted. It's a moment of intense focus. Hashtag tag outro.
This has been an incredibly complex and important analysis. Let's quickly review the major takeaways from the source material for you, our listener, just to pull it all together.
Okay. We established that Huntington's disease is defined by a specific catastrophic genetic defect that expanded CAG repeat in the HTT gene on chromosome 4. This leads to the devastating and generational 50% inheritance risk driven by the toxic gain of function in the mutant Huntington protein.
Great, the toxic protein.
We then explored the emerging promise of gene silencing therapies, with companies like Wave Life Sciences utilizing ASOs delivered via lumbar puncture, and Unicor aiming for more permanent solutions with viral vectors. Critically, these are showing early success in reducing the toxic protein levels in the CSF. That's the big news.
And culturally, this scientific moment has intersected with intensely personal narratives shared online, driving critical ethical questions to the forefront. These include the profound personal dilemma of pre-symptomatic testing, would you want to know? and the societal conversations around balancing the hope of gene editing with the regulatory reality, specifically concerning pre-implantation testing and gene editing to prevent transmission. This is really the front line where science meets destiny in a way.
Yeah, it really is. And this conversation holds immense value for all of us, I think, because as gene editing becomes more prevalent, the ethical decisions surrounding HD, whether to know, whether to edit, whether to prevent, will inevitably intersect with deeply personal choices that will affect the entire trajectory of genetic medicine for future generations. These aren't just questions for HD families anymore.
They're becoming questions for everyone. So let's leave you with a final thought to mull over, building on that debate around preventing transmission. If the scientific community can eventually eliminate the inherited risk of HD through editing or pre-implantation testing, what moral obligations, if any, do future generations have to use such technologies? Is there an obligation to prevent it, if we can?
And sort of extending that, how does society define a disease that is deemed worthy of mandatory or highly encouraged prevention, effectively breaking a family line of inheritance forever? Where does individual choice end and societal expectation begin?
That decision shifts the burden from the carrier to the collective, perhaps. And it's a question society must wrestle with as science continues its relentless progress in making this seemingly impossible, the elimination of generational disease, a matter of personal choice and, eventually, public policy.
It's a huge conversation we're just beginning to have.
That is where we leave our analysis for today. Thank you for joining us on Trending Unpacked. We'll be back soon with more stories behind the trends shaping our world.